Bond order. The number of covalent bonds formed by the overlapping of atomic orbitals and the relative stability of the molecule thus formed can be shown by the quantity known as bond order. It is defined as bond order. It is defined as 1/2 of the difference between the number of electrons in the bonding orbitals and the number of electrons in the anti-bonding orbitals. That is, bond order is equal to half into number of electrons in the bonding molecular orbital and the minus number of electrons in the anti-bonding molecular orbitals. If Nb represents the number of electrons in the bonding orbital and Na represents the number of electrons in the anti-bonding orbital, we can represent the bond order is equal to half into Nb minus Na. Then, significance of bond order. Once you determine the bond order, it is easy to determine the stability of the molecule. 1. Stability of the molecule. If Nb represents the number of electrons in the bonding orbital and Na represents the number of electrons in the antibonding orbital, case 1, if Nb is greater than Na, the molecule is stable. This is because the number of electrons responsible for stabilizing the molecule is greater than those with destabilize the molecule. In this case, the bond order will be positive. 2. If Nb is less than Na, the molecule is unstable. This is because a higher number of electrons present in the antibonding molecular orbitals increases the energy of the system and destabilizes the molecule. In this case, the bond order is negative. Hence, a negative value of bond order implies that the molecule is unstable. C. If number of electrons in the bonding orbital is equal to the number of electrons in the antibonding orbital, that is Nb is equal to Na, the molecule is again unstable. When equal number of electrons are present in the bonding and antibonding molecular orbital, there is no net force of attraction between the combining atoms and the molecule is rendered unstable. Hence, zero value of the bond order implies that the molecule is unstable. By getting the value of bond order, you have to write all these factors. You have to find out whether it is stable or whether it is not stable, etc. From the above discussion, it may be concluded that the molecule is stable only when the bond order is positive. The molecule is unstable when the bond order is 0 or negative. Fill in the blank question can be asked. Now, second, status of the bond. The bond order concept in the molecular orbital method corresponds to the concept of chemical bond and predicts the status of the bond. The integral bond orders 1, 2, 3, etc. corresponds to single bond. That means if you get a bond order 1, it is a single bond. If you get a bond order 2, it is a double bond. If you get a bond order 3, it is a triple bond. Now, next one is bond length. Bond order also helps in predicting the bond length. Bond order found to be inversely proportional to the bond length. Fill in the blank question. Bond order is found to be inversely proportional to the bond length. Hence, higher the bond order, shorter the bond length. Another fill in the blanks. Higher the bond order, shorter the bond length. Now, fourth point. Magnetic behavior of the molecule. When all the electrons in a molecule are paired, the molecule is called diamagnetic. However, when one or more electrons in a molecule are unpaired, it is paramagnetic. This also you have to write. Magnetic nature of the molecular orbital. If a molecule possesses one or more unpaired electrons in its one or more unpaired electron, its bond order is fractional. Then, therefore, a new rule. This can be applied when you have to determine whether the molecule is a paramagnetic or diamagnetic. Therefore, a fractional value of the bond order indicates that the molecule is paramagnetic in nature. When the bond order is a whole number, the molecule may or may not be paramagnetic. That means if it is a fractional number, surely it is a paramagnetic. But if it is a whole number, you have to check whether the electrons are paired or not. If it is unpaired, it is paramagnetic. All these rules we require in order to write the electronic configuration of the molecular orbitals of the elements from hydrogen to neon. That is the first two periods in the periodic table.